Hey, welcome back. In this video, we are going to see how we can create an X11 window in Ruby C extension. Now, by X11 window, I mean it will be a very basic window with maybe some text like hello world or something like that. And then there's another code I have that will show Arch is based, which is my current distribution, Arch Linux. So actually, I picked this example because you can just Google Arch is based. Just a moment. You can just go to google.com and say Arch is based in programming languages, something like that. You can see that there is a link, Arch is based, and you can open it. And here are various codes in various programming language. As you can see, we have AppleScript, Arnold C, ATS, awk, basic, batch program, burl, boo, etc, etc. We have also C program, which will just print the string Arch is based. But we don't want to have a textual program, right? We want to create one graphical program. So in that case, oh wow, by the way, we have also CSS program, which is setting the pseudo element before with Arch is based, which is really exciting, by the way. Yeah. Let's go back to our X11 program. So as you can see, it is also a C program, right? There's also the puts Arch is based program, and it is the graphical X11 program. So actually, let's start off with our Rosetta code first. I'll link it down below. As you can see that, just a moment. Yeah. So this is one C program using the xlib, which is just X11, and we don't need that part. We just can compile our code with -lx11. So we will be learning how you can use the LD flag and C flags as well, but probably we won't choose the C flags here, but we will see how it works. So let's copy our code and create a new directory called, maybe let's call it X11 hello, cd into it, and now let's create one file called, what should I call it, x11.c. all right. If I paste it, as you can see, we have the pasted code, and if I can compile it, to compile it I actually need to have -l capital X11, then our program name x11.c, and it will reproduce a.out. But if you miss the part here, you will see that we are having LD error. We cannot link it, right? So we need the LX11, and the recommended way is to have no space in here. It is the same thing. So if I run our code a.out, you can see that we have hello world program. Let's write it in for the Ruby C extension, right? So first I have to create one file called xtconvert.rb and require mkmf, and then we will create our make file called x11, what we called our program. Let's say this. We have the x11.c, right? So let's call it x11 program, maybe prog, and it will generate our x11 prog.so. Let's edit our x11.c as well and remove our int main, and first include our ruby.h header file, and then we will have value, and then let's call it x11. Maybe it can conflict, so let's append one underscore. This may be not the recommended way, but I prefer this underscores. Let's have volatile object here called value, sorry, volatile value obj. And so it is taking no arguments, but Ruby passes the obj all the time, which is a main object in Ruby. Now let's refactor our code a little bit, remove the empty spaces given by our Rosetta code. Now let's create our Ruby function. To create our Ruby function, I will do void, let's call it, it should be called as x11 prog. So we have to do init x11 prog, And inside the function, we can define RB, define global function, and let's call it X11. And then we will call the hyphen X11, and it takes no arguments. So if I compile this code with Ruby xtconv.rb ampersand make, and if I require this Ruby minus R X11 X11 prog.so and run it, X11, it's a normal method. As you can see, we have some undefined symbol xfill rectangle. So we will have some undefined symbol as we have seen in this part. Now that we have the error, we can edit our code and see how to utilize the LD flags and C flags as well. So let's first edit our xtconv.rb and let's see what we have in our LD flags here. It should be a $LD flags because it's a global variable in Ruby. So if I run ruby xtconv.rb, as you can see, we have -l, -wl, whatever. So it's -01, which is optimize one, short, common, whatever. So because this is a string, right, we can have ldflags.class and we get string back, right? So it's a string, just a string. So we can just append our -l X11, but there's a problem. Let's compile and run this code. If I run ruby xtconv.rb ampersand make, as you can see, we have cannot find entry symbol export dynamic -l X11. So we need one space in here, right? Never ever forget the space. We can also have this, whatever, but you should have a space here. Now, if I run this, I get creating makefile, linking, whatever. And now if I again run our Ruby code, ruby -r X11 prog, and as you can see, calling our function gives us the hello world window. Now let's open our IRB just for fun, and if I require X11 prog, as you can see, we have true, and if I run X11 function or method, we get the hello world back. Now let's edit our code and add some parameters. So we can pass the string as a Ruby string, of course, and we will use the string value ptr to convert our Ruby string into a C string. To do that, I will edit our x11.c file again, and let's edit our X11 function in here. So we will have a volatile value, let's call it str or maybe message, whatever, it doesn't matter. And as you can see, we have the constant character message in here, which we can just replace with our string value ptr function, and let's pass our message in here. So we will convert our message from the Ruby object. And this program will take one more argument, right? Volatile value obj is really important because as you can see, we don't use the volatile value obj, right? Our GCC can just remove this whole variable from here, and we will be left with volatile value message. So we don't want that. We want volatile value obj, and to be safe, I am also using volatile value message because for some reason, if I take 3 arguments and I do not use the last one maybe, and I don't want GCC to remove our variable, right? So in that case, we want the volatile to prevent any removal or optimization from unneeded variables. So anyway, if I run this code again, and let's compile our code, and let's also copy what we have in here. And if I press enter, we have wrong number of arguments, of course, because we need to pass arguments here right now. So if I pass px11 hello, as you can see, we have hello, pretty exciting, right? And if I say something like 5, it will of course give conversion error, right? Type error. So because it's an integer. But if I do 5.2s, as you can see, we have 5. and we should not also compile this code all the time. We can just require it. It is 11 prog. So as you can see, we have required our X11 prog, and if I run X11 say HELLO and two spaces WORLG for some fun. As you can see, we are having hello world overflow here, and we can just expand our screen or maybe the window to get our whole hello world message. We can also maybe set our window size and so on. Now this is very basic, but as I promised, I'll also show you the Arch Linux example here. We have the X11 program, right? Now let's copy it and paste it in our X11.C program. Let's cut everything. And modify our code a little bit to just fit it. Instead of int main, I'll remove int main as well. Everything like that, include and stuff. We have the pretty similar code in here right now, and if I run this, I'll say it should compile and say Arch is best, right? So we don't have actually utilized the message here. As you can see, it's saying Arch is best. And also let's now see what our C flag does. So if I do nano, let's edit our xtconf.rb, and if I print our $C flags in here and run ruby xtconf.rb, it is march x8664 mtune generic minus optimized2 pipe fno plt and fpic. But if I also run our irb and run rb config and then get our C flags from here, you can see it is exactly the same thing. So this is how our Ruby environment knows about our C flags. This is what our, my Arch Linux distribution did when compiling this Ruby. But for some reason, if I run, maybe I do have RVM, so if I use the RVM, and then I do have Rubies, and there is Ruby 2.7, I think. Yeah, 2.7.2. And if I run Ruby from our bin directory and run our xtconf.rb, I get -03 minus march native minus mtune native and fno plt fpic. So what this does is actually I have compiled my own Ruby with these flags. So it uses optimization level 3, which is kind of faster than optimize level 2. So your whole Ruby is faster by some microseconds for some more small task, but it is faster, right? So if you are doing a very huge task, maybe that can take some hours. So you will be saving maybe a couple of minutes or maybe 30 minutes with -03 level optimization. So if I again run our Ruby with -e and see what our C flags has, rb config, and then get C flags, we also need to put the value. As you can see, it is exactly the same. So this is how the C flags is getting fetched, and we also do have LD flags, right? So as you can see, we have these LD flags, and this is how the C flags and LD flags are fetched. So if I again edit our xtconf.rb and append our -03 level optimization, it should be O, not 0. So 03 minus march equals to native minus mtune equals to native, and we can also clear out our C flags as well, right? The older C flags. Dot clear. So string dot clear actually clears out everything that the string has. So we should have only this string in our Ruby environment in the global C flags variable. If I again run our Ruby xtconf.rb, see, I forgot the F. Sorry for the typo. And if I run this code, I get -03 March native M2 native. I can remove this space as well. And I can also use the ldflags.clear to clear out what our ld flags as and see what happens. Also, if ld flags is undefined, we can use our safe navigation operator in Ruby to make sure we don't call the clear method on nil class. So in case of ampersand syntax, you can have no spaces as well, but I prefer spaces. So with this, if the C flags is nil, it will not call the clear method and it will just return nil. But if C flags has something, if it is not nil, it will call the clear method, right? So if I again use our make command like this, as you can see, it is the same thing. So we have cleared out our unnecessary ld flags, but sometimes I don't recommend using to clearing out ld flags. You can clear out C flags, and because it is up to you, right? So if you were writing some program that defines some other ld flags and you don't need the Ruby ld flags, you will always try to clean it out. So that's the reason I showed it to you, but it doesn't matter. We can always compile our code, and yeah, that's it. So that's how we can create our X11 windows in Ruby. And using this, I think you can also create GTK windows or Qt application, Qt applications. You don't have to learn the Ruby specific things. You can always use the C programming language, which is actually not really that scary, right? It is quite easy to do. I will say that rather than finding documentation for the GTK on Ruby, which is really hard to get, the documentation is really bad and it is not intuitive. So I'll just prefer writing my own GTK window in C and call that from Ruby. In that case, I will have total control on what I'm doing, right? So yeah, that's it for today's video. I think you learned something new. If so, please don't forget to like, subscribe. I do thank you for watching and hope that you have a great day.